try and repeat the example we just had of adding a value of 1 to our heat value. If we middle click on this node, we can see, so if we dive down inside the SOP solver and middle click on the object merge, we can see that we're getting our geometry, we're getting our point attribute heat, and we're getting our variable heat. So I can use an attribute create, and I can set it up to change the value of heat, and I'm going to change it to $heat plus 1. And what we should find is that now, as we increase the frame, the value of heat increases. And that's because what's fed back into this network at each frame are the values that existed at the previous frame. So we start with a value of 1, it's fed in, we add 1 to it, it becomes 2, that's fed back in, it becomes 3, and so on. Let's go back out to our box object and have a look at that. So here we are at the scene level, and the shelf tool, when we used it, has helpfully created this DOP import, which is bringing information in from the DOP network. And there's our heat attribute, and if we move frames, we see that our heat attribute resolutely stays at 0. The reason for that is that by default this DOP import is set to transform input geometry groups. In other words, it just takes the geometry here and transforms it based on the results of the DOP simulation. So our data that we had in DOPS isn't being brought back in. We need to change this, and we need to change it to fetch geometry from DOP network. And now, when we play the simulation, we should find that the value of heat goes up with every frame. I should remark, by the way, that when we created our RBD object here, it's worth going into the collisions tab and turning off use volume-based collision detection. There's a danger if you have a complicated object that it would take time to create the bounding volume for the object, and we don't actually need that because we're not using it in collisions. So let's now look at a way of spreading out a value between points. And I'm going to visualize the value of heat, and I can do that by clicking D to bring up the options for our 3D view, and then looking at this custom options setting here, and I'm going to create a text attribute. I'm going to then right click on it and edit it, and we're going to call it heat. The label is going to be heat, and the attribute is going to be heat. It's a point attribute, so we can leave that. And if we apply that, we now get here on our custom attributes display button the option to select heat, and then we will see that it has the value of 2 here and 1 everywhere else, and that's because we've added 1 to it. But what we want to happen is to start with a value of 1 here and a value of 0 everywhere else, and then we want this point here to have a look at its neighbours, and if there's enough heat in the neighbouring points, it should start getting warmer, and this should continue so that when this heat becomes hot enough, the next point will also become hot, and so on. It will start spreading down our matchstick. And to do that, we're going to need to create a VOP SOP. We don't do it here in our box object, we need to do it here in our SOP solver. So let's get rid of our attribute create, and let's have a VOP SOP. Here it is. Let's dive inside and open up the view. So rather than going through the building of this VOP network step by step, I'm going to start with the first few steps, and then I will pause the video and come back when the network is fully built. And remember, the SOP just loops over every point in our geometry and does a calculation based on that point. So the first thing we need is a neighbor count. And what the neighbor count does is take a point number. It also takes a number of the input that we're interested in, but here the input, there's only one input, which is input number 0. What it does is take the point number and tell us how many neighbors there are to that point, how many points are connected to that point directly, and that gives us a count. What we want to do is loop over all the neighboring points, total up the value of the attribute we're interested in, and then get an average. So let me just construct that part of the network and then come back. So this is the first part of our SOP network, and we're using these effects nodes neighbor count, and then we're taking that count, which is the number of directly connected points, and we're feeding it in as the end value of a loop. So that loop is getting every neighbor, point number of every neighbor. It's then importing the attribute, value of the attribute at that point, and it's adding that value to the total, and then it's returning the result. So the total is just a constant going in, which is going to be used to store the total of the attribute. The attribute name is the name of the attribute we want to total. And then, as a final step, we're taking the total and we're dividing it by the neighbor count, and thus getting an average. And then, for the purposes of testing the SOP network, I've added an attribute called average, which will contain that data. So if we go to our object and have a look at a details view, we should see that there's an attribute called average, and if we scroll down we can see that in some cases the average is 0.75, 0.66, as we would expect, and on a very few occasions it will be 1. So that's the first part of our network. The next part of our network is going to look at how we add a value to our attribute if the average of the attribute around the neighbors of that point that we're interested in is higher than a threshold. So once again I'm going to pause the video, construct that network, and then come back.